So molecules, which are electronically asymmetric, have a permanent dipole. There's a permanent partial positive and a permanent partial negative. And we can bring that into our Lewis dot structures. When we're drawing Lewis dot structures of a molecule, we first start with the skeletal arrangement. So you have your center atom, and then all the other atoms will bind to the center atom. Hydrogen can only have 2 electrons. It will never be a central atom. If there is a carbon, it will always be a central atom. And then you first figure out how many electrons you have to work with. And so we add up the valence electrons of all the atoms present. And that's the total number of electrons we have to operate with. And if there's a negative charge, we add extra electron. If there's a positive charge, we subtract an electron. So let's do nitrogen trifluoride. Nitrogen is in group 5, fluorine's in group 7. There's 3 fluorines, so 3 times 7. We have 26 total valence electrons to work with. We draw our skeletal structure. Now that took 3 bonds. Each bond is 2 electrons. So I've used up 6. I have 20 left. And then I fill them around. Now, is this a good structure? Does each atom have 8 electrons? Fluorine does. 6 of its own and 2 shared. Fluorine does. 6 of its own and 2 shared. Fluorine does. 6 of its own and 2 shared. Nitrogen does. 6 shared, 2 of its own. So this is a good structure. Formaldehyde. Again, the least electronegative atom is typically put in the center, and if you have a carbon, carbon is always in the center. I have 12 total electrons to work with. 4 valence electrons from carbon, 1 from each hydrogen, and 6 from oxygen. And I've used up 6 here with my 3 chemical bonds. I have 6 more. So let's put them all in oxygen. Is this a good structure? Well, my drawing is not good. Alright, so they're all in oxygen. The 2 hydrogens are happy because they have the 2 valence electrons. They're like helium, they're happy. And oxygen is happy. It has 8 valence electrons. But carbon is not happy. Carbon only has 6 electrons and it wants 8. I need 2 more, but I don't have 2 more. I've used all 12 of mine. This is how we make double and triple bonds. My only option is to share. So I take these 2 electrons and I share them to get a double bond. And now the carbon has 8 electrons and the oxygen has 8 electrons. Remember, the shared ones get double counted because everyone claims the shared electrons as their own. Carbon monoxide. We have 10 valence electrons to work with. 4 from carbon and 6 from oxygen. I use 2. I have 8 more. So I put them in there. Is that a good structure? No. Both carbon and oxygen only have 6 electrons. So you can share 1 pair. And oxygen would be happy. But carbon still wouldn't be happy. Because it only has 6 still. So we have to share another pair. And that's how you get a triple bond. And now with the triple bond, the carbon and the oxygen each claim 8 electrons. 2 of their own and 6 shared. Remember, the shared get double counted. Each atom claims it as their own. Here we finally have a negative charge. So when we do the Lewis dot structure for nitrite, you get 5 for the nitrogen, 6 for each oxygen, but then 1 more for the extra electron to have 18 total electrons. And now we draw our skeletal structure. We've used up 4 electrons. We have 14 left. We place them around. And is that a good structure? No. Nitrogen only has 6 electrons. So we have to share from one of the oxygens. But which one? They're both equivalent. And the real answer is both. This leads us to resonance structures. A lot of times you cannot draw an accurate chemical structure with a Lewis dot structure. And so we need resonance structures. In a resonance structure, what we're saying is the compound is 50% this character. And 50% this character. It's not flipping back and forth, it's just 50% that and 50% this. In fact, if you do an X-ray crystallography of this compound, you don't have a double or a single bond. Both bonds are about 1.5 bond lengths. We can do the same thing for carbonate. You have 4 valence electrons for carbon, 6 for the 3 oxygens, and now it's -2, so we add 2 extra electrons. We have 24 electrons, we draw our skeletal structure, we use our 18 electrons and we fill it up. Now we're out of electrons, but carbon's not happy, so we need to share a pair. But which pair? All 3 are correct. And so carbonate is actually a resonance structure of all 3. It is 33% each of these. And if you see it under X-ray crystallography, all the bond lengths are about 1.3333. All right. For polyatomic ions, you'll see both covalent and ionic bonding. So for like sodium carbonate, you have the covalent bonds of carbonate, and then you have the ionic bonds holding the sodium pluses with the carbonate 2 minuses. So with these molecules, you'll see both ionic and covalent bonding.